everyone. I'm Bashar. You are watching the channel Techquest Learning Point, and I'm here with a new episode of the tutorial Programming C Sharp for Beginners. Today I am going to start sixth episode on the new topic arrays in C Sharp, and it's the sixth episode of this series of tutorial Programming C Sharp for Beginners. It's a complete C Sharp programming course which enables any learner to make their basic foundation on C Sharp programming, where five number of episodes has already been discussed with lab in Visual Studio 2022 environment. In this episode, I will discuss on understanding arrays, declaring and initializing arrays, working with array elements, multidimensional arrays, and jagged arrays. As well as I will show with example to make your concept more clear in Visual Studio 2022. Okay, let's start. Understanding arrays. Arrays in C Sharp, a data structure that store a fixed size sequential collection of elements of the same data type. In simply, we can say that the array is one kind of variable which can store same type multiple data. Purpose: to efficiently manage multiple values of the same type under a single variable name. When several values of same type, such as marks of many students, are needed to store in a single variable. Key characteristics: fixed size. Once created, the size of an array cannot be changed. During declaration of array, how many values to be stored will be fixed and it cannot be changed. Sequential storage. Elements are stored in contiguous memory locations, allowing efficient access by index. Values are stored sequentially positioned, and each value can be tracked by number called index. Same data type. All elements in array must be of the same type. If all students' name are values, data type will be string. Declaring arrays. Have a look into the syntax of the declaring array. Data type square bracket array name equal to new keyword data type square bracket array size. Example: int square bracket students age equal to new keyword int square bracket 50 semicolon. Here students age variable can store 50 number of integer values. Data type. The data type of elements the array will hold, as per example, integer, string, double. Array name. The name you assign to the array. Size. The number of elements are the number of elements the array can hold. There are some important points. Arrays can be multidimensional. As for example, arrays of arrays for representing matrix or multi-level data structures. Use the length property to get the number of elements in an array. C# also offers other collections like list, dictionary, and hash set with different features and flexibility. Declaring and initializing arrays. Declaring arrays. Specifying data type and size. Data type square bracket array name equal to new data type square bracket size semicolon. Example: int square bracket price equal to new int square bracket 5 semicolon. Here declares an array of 5 integers. An array variable price can store 5 numbers of integer value. Implicit size inference. Data type square bracket array name equal to value 1 comma value 2 comma example string square bracket names equal to Alice comma Bob comma Charlie implicitly creates an array of three strings. Array elements can be initialized in many ways. Individual assignment array name square bracket index equal to value. Example numbers 0 equal to 10 semicolon. In this way we can initialize the individually. Initializing during declaration. Array variable can be initialized during the declaration. The syntax you can follow. Data type square bracket array name equal to value 1 comma value 2 comma example int square bracket ages equal to 25 30 comma 35 accessing array elements value equal to array name square bracket index example int first number equal to numbers 0 semicolon retrieves the first element 10 we should keep in mind the following points at the time of coding with array. Arrays are zero based, meaning the first element has an index of 0. Attempting to access the element beyond the array's bounds result in index out of range exception. Use the length property to get the number of the elements in an array. Int array size equal to numbers dot length semicolon. In this way we can find the total length of array. Additional examples declaring and initializing a multi-dimensional array 2D int square bracket comma matrix equal to new int 3 comma 4 semicolon. Here are 3 rows and 4 columns. Initializing a jacked array of arrays with varying lengths string square bracket names equal to new string square bracket 2 square bracket semicolon names 0 equal to new string square bracket Alice comma Bob semicolon names square bracket 1 equal to new string square bracket Charlie comma David comma Emily. Working with array elements, let's discuss the array elements with an example. An array element is a single piece of data stored within an array. Imagine an array as a collection of boxes lined up in a row, each holding a different item. Each item stored in a box is an element of the array. Here's an example to make things clearer. Let's consider a scenario. You have a grocery list stored as an array called shopping list. Shopping list equal to square bracket apples, comma milk, comma bread, comma eggs. In this array, there are 4 elements apples, milk, bread, and eggs. Each element represents a single item you need to buy at the grocery store. The element apples is located at the first position, index 0 in this array. The element bread is located at the third position, index 2 in the array. Accessing and manipulating elements. You can access and manipulate individual elements in an array using their index position with the square brackets. Here are some ways you can interact with elements. Accessing an element. Grocery item equal to shopping list square bracket 1. This will store milk in the variable grocery item. Modifying an element shopping list square bracket 2 equal to whole wheat bread. This will replace bread with the whole white bread. Adding an element shopping list dot append cg. This will add cg to the end of the list. Removing an element del shopping list square bracket 0. This will remove the first element apples from the list. Types of elements. Array elements can hold various data types including numbers 1 2 3 4 strings apple banana cherry booleans true false true objects square bracket curly brackets name colon John age 30, comma, name Jane age 25. Even other arrays 1, 2, 3, 4, 5, 6. Array elements are the individual pieces of data stored within an array. Each element has an index position that helps identify its location within the array. You can access, modify, add, and remove elements using their indexes. Any elements can be of various data types, from simple numbers to complex objects. I hope this explanation and example provide a clear understanding of array elements. Feel free to ask if you have any further questions or comments. Multi-dimensional array. A multi-dimensional array is a more complex data structure that goes beyond the simple linear structure of a one-dimensional array. It like having multiple arrays nested within each other, creating a higher level of organization for your data. Here's an example to break it down. Let's consider a scenario. Imagine you are running a movie theater within 5 rows and 10 seats. In each row, you want to track whether each seat is occupied or not. One dimensional approach. You could use a single array of 50 elements, 5 rows, asterisk 10 seats. Each element would be a Boolean value representing whether a seat is occupied, true, or vacant, false. This works, but it becomes cumbersome to access specific seats and analyze seating patterns for different rows. Two-dimensional approach. This is where a multi-dimensional array becomes in. You can create a 2D array with 5 rows representing rows in the theater and 10 columns representing seats in each row. Each element within this array would be a Boolean value indicating the seats occupancy. Theater seats equal to square bracket, false, comma, true, false. Now accessing a specific seat is much easier. You can use two indices, the first for row number 0 to 4 and the second for the seat number within that row 0 to 9. For example, theater seats 2, 3 would tell you whether the seat in the third row and fourth seat is occupied. Benefits of multidimensional arrays. Organize complex data. They efficiently store data with inherent structures like tables, images, or grids. Simplify accesses and analysis. Accessing and manipulating specific data points becomes more intuitive with well-defined indices. Perform powerful operations. They enable advanced operations like calculating seat availability per row, finding empty seats for a group, or analyzing seating trends. Application of multidimensional array. Image processing, representing pixels in an image. Game development, storing game maps and character positions. Scientific data analysis, storing and manipulating scientific data sets. Financial modeling, tracking financial data over time across different categories. Jagged array. A jagged array, also known as a racked array or irregular array, takes the concept of multidimensional arrays a step further by following its sub-arrays, that is, the arrays within the main array, to have different lengths. Imagine it like uneven stairs, where each step can have a different number of bricks. Here's an example to make it clear. Let's consider a scenario. You are organizing a movie night for some friends, and each friend wants to watch a different number of movies. You want to store their movie choices in a data structure. First, we perform this scenario using traditional 2D array approach. You might try using a 2D array with dimensions equal to the maximum number of movies any friend wants to watch. Let's say 5. However, this wastes space for all the friends who have fewer choices. Movie choices equal to square bracket, Star Wars, Lord of the Rings, Spider-Man, The Godfather, Casablanca, Citizen, Kane, Pulp Fiction, reservoir dogs, etc. If we perform the same work by using jacked array approach, a jacked array comes to the rescue. Here, each friend's movie choices form a sub-array within the main array, and these sub-arrays can have different lengths. Look at the image, movie choices. Now you only allocate memory for the movies each friend want to watch, making this a more memory efficient approach. Benefits of using jacked arrays: memory efficiency. You only allocate memory for the data you actually have, unlike fixed size multidimensional arrays. Flexibility accommodates data with naturally varying lengths without wasting space. Simplicity can sometimes be easier to represent and work with than complex nested structures. Applications of jacked arrays. Representing the tree structure, each node can have a variable number of child nodes. Storing irregular data, text documents with varying line lengths, music albums with tracks of different durations, etc. Parsing input data, where the structure of the data is not fixed beforehand. Key differences between jacked and multidimensional arrays. Subarray lengths. All subarray lengths in a multidimensional array have the same length, while those in a jacked array can vary. Representation. Jacked arrays may require more complex memory management than fixed size multidimensional. Remember, choosing the right data structure depends on the specific problem you are trying to solve. Jacked arrays offer a powerful tool for working with data that has inherent variability in its substructures. Feel free to ask if you have any further questions or want to explore specific examples of utilizing jacked array in different contexts by using comments. Now I'm going to write a small program using array in which I will show how to declare, initialize, accessing and modifying the array variable. Now run the program and show the output. Four items printed.
Now I want to run the program to show the output after modifying how it will be. This is the item list before modifying. Shopping list after modifying. 3 products will be the same, but the third product will be modified. Here the bread only. Here is the whole wheat bread. Here the array variable shopping list is declared and initialized by 4 values: apples, milk, bread, eggs. A string variable shopping item is declared to show how to access with each element of the array variable shopping list. At the first iteration, I is 0. Here write the for loop. For loop already I discussed in my previous episode. Here each element is accessing the variable shopping item iteration by iteration. At the first iteration, the first element apples is assigned to the shopping item. In this way, we can access any value of an array variable easily by using the for loop or any other loop. This line simply print the value stored in the variable shopping item, iteration by iteration. Third element of the array variable shopping list, that is bread, will be modified by whole wheat bread. This line simply print shopping list after modifying. Here shopping list array variable print all values iteration by iteration. In order to show the item number beside of item, the addition of 1 and I is printed in that position. That's it. I hope the declaration, initialization, modifying the array variable will be clear.